Assalamu alaikum. Our today's live session will be related to the further commands which are categorized as the complex commands. First of them is the sweep command, and other is helical sweep, and so on other commands. So as in the previous lab session we have done the revolve command in details, and in this lab session I will be giving the instructions for sweep command. So I have opened this spot module and the planes are in trimetric mode. So first of all, let us set them in the isometric mode. So go into file, into options, and here go into the model display, and from this pull down menu select, and the default model orientation select here isometric, and now click on apply, and just you can press enter here, and in the crew parametric option dialog box you will simply be clicking on no instead of yes, and the planes will be oriented in isometric mode. So as for the sweep command, as the name indicates, sweep means that some cross section will be swept along a given trajectory or path. Just like, for example, you can assume simple water pipe. So it has a constant cross section, but it has a central line which is followed by that cross section, or that cross section is followed by that center line. So that is the simplest example of sweep command. Means a cross section is swept along a given path or trajectory. For example, assume a cylinder having constant radius or diameter and having its length or height to be some given value of, for example, say 5 meter. So if its cross section is circular, so that circle will be swept along its length or height. So a solid cylinder will be generated. So that is the simplest way, but the trajectory may adopt any shape. So here we will be observing the limitations of the trajectory for the sweep command. So as we have observed in the previous commands, that the profiles for any command can be created using either the external profiles or the internal profiles. But for this command we will be observing that this command is partial internal and partial external. What we will be observing in detail, that the trajectory for the case of sweep command, the trajectory for the case of sweep command will be always drawn using external profiling, but the cross section will be created as the internal profiling. So for example, let us start. As we can observe here, for example, I am directly clicking on the sweep command, directly launching the sweep command. So here you can observe, we as soon as we have selected the sweep command, and the references dialog box is there. This first tab is the references tab instead of the placement tab, as we have observed in the previous two commands, in the revolve command and the extrude command. The first tab here was placement tab, but here in the sweep command the first tab is the references tab. But in the references tab, as we observe here, it shows the trajectories. So as you can observe here, it says select items, and we have observed in previously that select items means that some item has been already created using external profiling so that it can be selected. If here it were written that define items, so that would mean that the item could be defined at the spot using internal profiling or internal sketching. But as here it is mentioned that select items, so by this terminology we understand that it means some external trajectory must be drawn. So because it is a trajectory, so that must be previously drawn using the external command. So but we have started the command sweep command directly. So how can we draw the trajectory externally? Now instead of cancelling this command, so we observe it here that we will be clicking on simply on the datum, and here we can observe that this first icon is the sketch. So this is the datum sketch which will be used to create the trajectory externally. So just click on here and you will be obtaining another sketch dialog box. So for example, I am creating the trajectory for the sweep command in the front profile, a front plane. So click on this front plane, and here you observe as soon as the trajectory process is being launched, this command has been set into pause mode, because here you can observe that the 3D feature sweep command is in the pause mode. So that means once the trajectory will be completed, then this pause will be deactivated and the command further 3D feature means the selection of the trajectory will be launched. So click on sketch, and here now you will be creating the trajectory. So you can click on sketch view, and for example you can create a random trajectory, and then we will be observing what are the limitations for the trajectory. And this type of trajectory actually you can say the sweep command basically is used for creating some piping system. For example, you are creating the model for a power plant, means for example assume some heat exchanger which where the tubes are in various in the series pattern and there are various bends. So this command can be used for creation of such models. So for example I can create a random trajectory here. As a simple demonstration, though we can create a profile for the center lines for heat exchanger, but for example I am just using this spline command. So for the spline command, for example I am just creating this sine wave shape here like this. For example, just to make you understand, this is some random trajectory just for the command demonstration, so you can make it better. Here it's control points, so like this. For example, you can further make it a bit logical shape like this. So this trajectory is sufficient for demonstration. So as soon as you can observe that I have created a random trajectory, and here just click on OK. And as now we can observe that, for example, we will first be setting it into the standard rotation, and the trajectory will look like this. And here now we will be clicking on this resume the previously paused tool. So now as soon as I have collected I have selected this active mode. So here you can observe that this trajectory has actually two ends. This trajectory has two ends. So the projectile, so the cross section, so the cross section which will be following this trajectory can be created or started to follow this trajectory from any end, from this end or from this end. So here you can observe that here the arrow by default is shown at this end. So that means this arrow actually representing that the cross section will be created at this end of the trajectory. Now for example, I can click on this arrow here, just simply click on here. So as you can observe that this arrow has been shifted to the other end. So that means now the cross section will be created at this point. And other settings are section plane control. Section plane control means normal to the trajectory. Means section plane control, what does it mean? That means the plane in which the section will be created will be normal to the trajectory at each and every point. So that means that the cross section will be here you can simply observe that, for example, this arrow is tangent to the start point. This arrow is tangent to the start point of this trajectory. So the normal to the this tangent direction. So normal to the this tangent direction, the cross section will be placed in that plane. Cross section will be placed in that plane, and that will be traveling along this trajectory at each and every point perpendicularly or normally. So that it means, so here it means a horizontal or vertical control, that means automatic, so you will not be changing it. And x direction reference start point, start default at start. So these two options will be left as it is. So we will not be changing any other setting from here. And here x and t, we will not be disturbing anything from here. We will simply be here you can observe we will be clicking on this section. In here it is written sketch. So here you can observe that the cross section for the trajectory will be created using the internal sketching. So the trajectory has been created externally, and the section for this trajectory will be created internally. So that means this command is partial external and partial internal. So any quiz point of view or any Viva point of view, you must remember this point, which is the clear difference between the previously demonstrated two commands, revolve and extrude. So click on here, and here you will be observing that as soon as I am clicking on sketch, so the cross section will be created at this end. Here I have now selected the sketch, and here you can observe that this here two perpendicular lines are actually drawn. Actually these are the perpendicular, you can say, the axis of the normal section plane. This is actually the section plane. The section will be drawn in this plane and will be normal to the start point, so at each and every point. So here for example I am simply clicking on here, though you can set it into the sketch view mode here like this, very clearly and concise manner you will be observing this thing, that these are actually the edges of the various default planes. Here for example here you can, for example, make the default planes off. So here you can observe that this is actually the start point of the cross section, and these two axes are actually the axis showing the normal plane, which is the section plane normal to each and every point of the trajectory. So click on, for example, I am using a circular cross section. So here I am creating a simple circle of smaller size as soon as possible, because I am randomly making you demonstrate this command. So you will be always be starting from the lowest size of cross section. Cross section can be of any shape, circular, rectangular, or any shape can be, but remember that must be the closed loop for solid modeling. So now click on OK, and then click on standard orientation. So here now you can observe that this is in the preview mode. So here for example you can set it in the front view. So here you can observe that this cross section has swept along this center line or this trajectory. So this is actually the simple demonstration for the sweep command. So here if I am clicking on OK, so that will be finished here, and like this model will be created. So again, for example, I am clicking on here and clicking on edit here in this edit definition mode, and I am but here a very important option here is that thicken sketch. So thicken sketch means actually that you will be, for example, creating a hollow tube. For example, you are creating a hollow tube, so that will actually be giving you a wall thickness. For example, if here, as you can observe here, for example, if you are zooming in here, you can observe that this is the wall thickness. If I am using the thicken sketch command, so this is a very important feature. So here, for example, I am increasing the thickness. For example, I am putting it into 10 units. So here you can observe the wall thickness have increased, and for example, if the wall thickness is further reduced, for example 2 units, so this is the wall thickness like this. So this option was very important. So this is the solid, and this is the surface mode, and again into the options there is nothing here. Important thing is capped ends, or capped ends we are familiar if we create the surface model, for example here. So as you can observe it, capped ends mean the ends will be actually closed, means they will not be opened. Here as you can observe that this is meant by capped ends, and this thing we had actually observed in the extrude command, the capped ends. So capped ends mean the ends are actually closed, ends are actually also creating a face like this. So if I am clicking on it here, I am unchecking it. So here you can observe now this face is actually open, and end faces are open. And if we check the cap ends option, so that means the end faces are closed. So this means further here is tangency, so we will not be disturbing it. It is let it remain in the default setting, and of that properties you can just rename it logically. So this was actually the simple demonstration of the sweep command. Here we have observed that the sweep command requires actually one trajectory and one cross section. One trajectory and one cross section. And again I am clicking on solid, and here for example on thicken sketch like this. So in this way this model has been finished. Here an important observation or demonstration or conclusion that you will be observing. For example, if I am again clicking on the edit definition, and here what now I am doing, that I am for example clicking on sketch, means I am editing the sketch, and I am increasing the size of this cross section. So here you will be observing that here the cross section size is for example 78.05. so if I am for example I'm just simply dragging, or I can input some value for the diameter. So I am randomly increasing the value of this cross section. So for example this is some random value, and again now I am clicking on OK. So here we again observe that the model has been created. So once again for example I am further increasing the size of the cross section again here. So once again click, again here the size actually the model is being created. Once again for example you are increasing the size of the cross section. The cross section is actually you can say is creating the feature. But again I am here for example further increasing the size. You will keep on observing. Keep on observing. I am demonstrating. Here actually you have demonstrated one important thing. Though you are observing that the shape has been actually distorted, but still the command has enough. For example, I am clicking on OK. I am clicking on OK. Let us the command has actually successfully been executed. But here is one important thing. For example, I am clicking on again on the edit mode, and again for example I am decreasing the cross section again to some logical value here. Again look it from the front. Again the cross section is of larger size. So again make it further reduced in size here like this. Actually what I want to make you demonstrate is that the size of the cross section, if the trajectory is complex. For example, I am at this moment I am modifying the trajectory in some way so that it have further sharp bends. So how I will be doing that? For example, click on OK, and If we want to modify the trajectory for this sweep command, so what we will be doing, that we will be clicking on this arrow, this triangular arrow, which is actually lists the further sub commands used. So here this is the section 1, means internal section, and this is sketch 1, which is actually the sketch available for this trajectory. So click on its edit definition here, and now what you will be doing, we will be making it, for example, a more having sharp turns like this, for example. Just you can observe it here like this, for example. We will just be giving it sharp bends, for example. I can say like this. This is this here, the sharp bends. Now again try that whether that cross section works successfully or not. So click on OK. So here the cross section is actually created. Again, for example, again transform this trajectory and further like this, for example. Here again click on OK. Here very important thing that I am telling you at this stage, that in the previous or earlier versions of this software, if the trajectory had sharp bends, then the command might fail. But in this software, as in the higher versions, there are actually improvements. So here the command is actually successfully working. But here, as you can observe here, that the solids are actually merging into each other. Actually, practically or physically, the creation of such part is very difficult or practically impossible. So that means the merging of solids into each other is actually not allowed. So here at this stage, actually the command is actually not being failed, or is not failing, but you might suffer in some earlier version, you might suffer problem if the trajectory has sharp bends. So remember, if the trajectory has sharp bends, so always use the smaller size of cross section. For example, I am again here, for example, I am editing this section here, for example, like this. Click on sweep command and its edit definition, and here click on sketch. So here in the 3D mode, for example, I am now again making its size very small, for example, again here click on OK. So here you can observe that actually at this stage, for example, if you look it from the front view, so here as you can observe that the sections are not merging. Here the section is defined, but here it is again merging. So in this way, in the earlier version, this command might fail, or if you are using, you can say, if the trajectory has sharp bends, if the trajectory is narrower or has sharp bends like this, so always use the cross section of smaller sizes as much as possible. But if the trajectory is smooth and has smooth bends, not the sharper bends, then you can use the larger size of cross section, sweep cross section. So actually only this important point was to be explained, but here I have now observed, because I have taught many earlier versions of this software, so that created actually issues and problems. So that is why I have tried to demonstrate you. So if you have some earlier version, or you might suffer some problem, so if you have the trajectory with sharp bends and narrower turns, so always use the sweep section having smaller sizes as much as possible, then this command will be successfully executed. Or if the cross section, if the trajectory is very smooth and no having no sharper bends, sharper turns, then you can use the cross section of larger sizes. So that was actually the important point. So this command in simple way has been expressed and demonstrated. So if you have any question, you can ask. Here it shows it has other options like variable section, so that can also be demonstrated, but for the time being leave it simple. I have demonstrated at the constant cross section and single cross section and trajectory which having the constant cross section. So just click on OK, and this command is demonstrated important options. So next command now that I will be demonstrating, for example, I am deleting this command. Here in the simple sweep, we have observed that it requires a trajectory and a sweeps section. So now the next command is actually, for example, I am also deleting this trajectory as well. So just show all the planes here like this. And now the next command here is the helical sweep. Helical sweep is actually created using spring like shapes. In some software this is used as the helix command. So helical sweep, as the name indicates, it is used to create spring like shapes, physical springs for example. So helical sweep, as the name indicates, that this command is actually a combination of sweep command and the revolve command. Sweep command and the revolve command. So helical sweep is actually based on two basic commands. One is the revolve command and other is the sweep command. So how? Because if you observe, for example, a simple helical spring having cylindrical shape, so as you can observe that cylindrical helical spring actually has a center axis for the cylinder of that helix. So that axis actually termed as the axis of revolution, like the axis of revolution was used in the revolve command. And other thing is that for the helical sweep is that the wire diameter will be used as the sweep cross section, and the center line, which is actually helically bent about the axis of the cylinder, is used as the trajectory. So here, for example, I can make you understand by downloading a picture from internet. So just wait a moment. So I have downloaded a simple helical spring from Google. As you are observing here, two pictures. So for example, this is a actually physical spring, helical spring, that you are going to create a shape like this. So this is a cylindrical spring having constant diameter, and here you can observe that this is actually the center line for this helix. For example, this is the spring and its front view is shown here. So this central line, this is the center, this is actually the central axis, and this is actually the axis of revolution. So here you can observe that I have actually told you that in the helical sweep you will be observing that this is the combination of two commands, two basic commands. One is the simple sweep and other is the revolve command. So from the revolve command, as you know, the basic important thing is in the revolve command is actually the axis of revolution. So the axis of revolution will be extracted from the concept of revolve command like this is the axis of revolution. And the other thing in the sweep command, because in the sweep command the important thing is the trajectory and the cross section of sweep. It means there are two important things in the sweep command. One is the trajectory and other was the cross section of sweep. So what will be the trajectory and what will be the sweep section? So from here you can observe that this cross section or wire diameter of this helix, that will be actually the sweep section, which is constant throughout. This section is constant throughout. So that will actually be the section or wire diameter D as shown here. So that will be the section for, and what will be the trajectory. So here you can observe that the trajectory realistically that must be like this simple helix, like this is the center line. But remember, the trajectory actually in the sweep command will not be like this. The trajectory will be simply the pitch points, means for example this point and this is the second point, this is the second pitch point, and this is the third pitch point, and this is the fourth pitch point. So all pitch points will be connected by a straight line, which will actually be acting as the trajectory. So that means a straight line connecting these pitch points will be used as the trajectory for the sweep command, and the wire diameter will be used as the sweep section for that trajectory for pitch points. So as you can observe that the pitch point, corresponding pitch points are same at each and every point here. So in this way that sweep section will be swept along that trajectory or pitch points, and this will be that trajectory will actually be revolved around this axis of revolution. So this is actually the concept. So you will further be understanding when I am making you demonstrate this command. For example, directly click on helical sweep. So all requirements for the revolve command, as we had actually observed in the revolve command, that the internal profiling or external profiling. So axis of revolution can be can be created in many ways. So those all methods will not be explained here, but just let us directly start the helical sweep command. And here what you can observe here again, that like the sweep command, here the first tab is the reference tab. So in the sweep command and the helical sweep, in both commands, here is the reference tab, the first tab. So here it says helix profile. So this is a very important thing, that what is the helix profile. So helix profile is actually, as I have told you already, that actually it is the straight line connecting the pitch points, these points means the cylinder radial points, means this is the radius for the cylinder. cylinder of helix. So the straight line connecting the pitch points or radial points, that is actually the helix profile. So helix profile for the cylindrical spring will be a vertical or horizontal straight line. For example, here you can observe that select items, and here helix profile can be created using external profiling and internal profiling equally. So here for example I can click on, for example, define and create the helix profile using internal profiling. So I am creating on the front plane. Again click on sketch, and here for example I am creating a straight horizontal vertical line. Here for example, here you can observe that I have created a simple straight line, and this line is actually, and you can observe it again here, that this point is actually connecting these pitch point, this 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 pitch. All pitch points will be actually connected with the straight line corresponding pitch points like this from the front view. So I hope you have understood this concept, which I have tried to elaborate you in the best way possible. So this is the actually cylinder radius. For example, it shows randomly 182, so make it for example 180 units, and this is actually the helix sweep profile. And here again you are observing that the arrow is at this end, so that means the sweep section will be created at this end. So but important thing is, at this stage the axis of revolution means the this central axis must also be created. That is very necessary. So for example I am creating on this datum center line, and for example I am making it coincident with this center line like this, sorry, here. So this center line is very important because this is acting as the axis of revolution. This can be anywhere and is parallel to the helix sweep profile. So the properties have been completed, requirements have been completed, so click on OK. Here you can observe that internal sweep section, it says, and its requirements are completed, and here it says helical axis internal CL, and this is actually the internal CL because that was actually the requirement for the revolve command. So the next task is that click on this sketch. So sketch will be created at this point here. So here if you want, you can for example click on this sketch view, and here you can observe these actually pink line. These are very important, so you can make other datums off here like this. Actually this is actually the you can say the origin or the default planes axis, and this is actually these pink lines. Somewhat you can observe their color difference from these axes. So this actually point is actually showing the start point of the sweep section. Here for example I am creating a helical spring having circular wire diameter. So just for example create a circle here and click on OK. And here as you will be observing that as soon as you have clicked on OK, so you have got this preview. So look it from the front here like this. So now a random helix has been generated, and you are observing it here. The helix sweep profile, which is actually connecting the pitch points using a straight line. So for example, if you want to create a conical helix, so you will be uh, slanting this line at the angle of uh, conical helix. So in this way, because this is the cylindrical helix, cylindrical spring, so having a constant radius or diameter for this cylinder. So in this way, this is the demonstration for the simple helical command. And here again, if you click on this pitch, so here you can observe that this is the default value for the pitch. So very important thing is there. If for example you will be observing one important thing, for example I am clicking on this sketch option and I am using some known diameter for this wire diameter. For example this is showing default 29. So for example I am setting it to for example 15. I have set the diameter for wire diameter to be 15 for example, and now I am clicking on OK. So here you can observe that for example my requirement is that I require one wire diameter gap between the consecutive coils. This coil and this coil, I want one wire diameter gap. So what will be the pitch value? For example, you can say if I am using the pitch value to be double the wire diameter. So what will happen? So let us see here. For example, I have used the wire diameter to be 15 millimeters. So I am clicking, inputting here, for example 30. So here you can observe that the gap between the consecutive coils is one wire diameter, because if you for example making the pitch equal to the wire diameter, if you make the pitch equal to one wire diameter, you will be observing that, for example I am inputting here 15. So here you can observe that the coils will be sitting one upon each other. So coils will be sitting over each other, so there will be no gap. Here you can for example check it out by zooming in here like this. So as you can observe it here, in every way that coils will be sitting. So here if you are making for example set it to 20 units, so here you can observe that the gap is actually showing here. So if we want one wire diameter gap between the consecutive coils, then we must use the pitch value to be double the diameter of wire. So make it 30. So this is the important conclusion, and Other is that we can create a helical spring of varying pitch, so that is out of scope, so that is not important. So again, other thing is here the thicken sketch. So thicken sketch is similar or quite similar like the what I have told you in the sweep command, simple sweep command, that actually thicken sketch actually creating a shell, a hollow tube. So you can click on, for example, thicken sketch here and observe here, for example. So just make this wire zoom in, and here you can observe that this is the shell thickness, this is the thicken sketch. So that means a hollow tube can be created. For example, here I am decreasing the thickness value to be 1 unit, for example. So here you can observe that this is a hollow tube, means having a constant wall thickness, so like this. For example, again you can verify it here. For example, you can click on view and click on first of all, for example, finish it here, the command, just finish it, and here, for example, click on view and go into the model plane section and click on planar section, for example, and here the reference plane, for example, you can click on, you can say for example, I can say front plane, for example. So here you can observe that the section in this side has actually vanished. So if we are again putting it in the front view mode, so here you can observe that these tubes are actually clear to you. So in this way the thicken sketch command has been also demonstrated. So you have actually verified the constant or uniform wall thickness using the sketch command. So click on OK, for example, and again here you can make this section delete, just delete this section, and for example click on delete this section here like this. So again, so this was very important command. So again go into its editing mode, for example, and see if other important option is there. So pitch value, okay, options, okay. One important thing is there that you can observe it here. Here it is by default, here it shows selected is right-handed rule. So that means this is a right-handed helix. So how we will be verifying whether a helical spring is right-handed rule or left-handed rule? So if the right-handed helix means if we hold the cylinder, this helical cylinder in our right hand, the top helix is actually ending in the direction of curling of your fingers of right hand. So just simply curl the fingers of your right hand in the direction of the top helix, in the ending direction of the top helix, and you are observing that this is ending in the direction of the tips of your fingers. So this is the right-handed helix. But if we click on simply on the left-handed rule, so again we will not be, remember, we will not be holding this helix in our left hand. The correct way is that again we will be holding this cylinder in our right hand, and the top helix is actually opposing the tips of our right hand fingers. That the top helix, the end of the top helix, again I can zoom in here, that this end of the top helix, because our fingers will be curled like this, so the tip of our finger will be here, so this will be actually opposing that the tip of our finger. So that means this is a, if the top helix is actually opposing the tips of the fingers of the right hand, then it is a left-handed helix. And if it is ending in the direction, for example like this, it is ending in the direction of the curling of the fingers or in the direction of the tips, then it is a right-handed helix. So this is the correct way of judging or estimating or observing or demonstrating the hand of a helix. So this is called the hand of a helix. This is the right hand helix or left hand helix, like this. So this important feature has also been explained. If you have still any question, you can fairly ask. So everything has been demonstrated. Again, for example, we can create you can say helical spring or of any shape. For example, I am turning this cylindrical spring into a helical a conical spring, like this. For example, what I can do, for example, I am click on again on this edit mode, for example profile section. For example, click on here you can observe, go into the, and here for example I am deleting this vertical constraint, and again for example I am just here like this, create it. So this is the top diameter, this is the bottom diameter. You can set it, for example, between dimension between this point and this point, or you can control its height like this. So I have randomly just tilted it or slanted it at some given angle. So just click on OK. Here you will be observing that the conical spring will be generated like this. So any shape of the profile, helix profile, can be used for creation of the helical spring. So the application for this helical sweep command is that we can create the threads, external or internal threads, or for example the fastening threads for lids of different bottles of various drinks. So this is the simple application for the sweep command, helical sweep. So these two commands have been demonstrated. Next important command that I will be going to demonstrate is the swept blend command. The next command is actually swept blend command. So let us demonstrate that command. So delete this previous command, and now the swept blend command, as the name indicates, that it is actually a combination. It is actually the combination of two commands. or the concept of two basic commands are actually applied further upon this command. One among them is actually here you can in the shapes area is the blend command, and other is the sweep command. So swept blend is actually composed of the methodology or working of two basic commands. One is the sweep command, and other is the blend command. So blending actually means various cross sections are blended or mixed up into each other. Means, for example, we actually approximate a particle or body at various locations along its sizes or path or its length. So for example, at the start its cross section might be circular, and some distance later its section actually changes into triangular or pentagonal or hexagonal or in any shape. So various cross sections will be blended or mixed up into each other. So from the icon of this command you can also observe here that this is the circular, and here on the other end the rectangular section is there. So how this command will be actually working, so let us start it directly. So let us start this command directly so that we are able to learn its requirements. So for example, I am clicking on swept blend command. So here you can observe that it actually, as I have told you, that is the combination of sweep command and the blend command, and you are familiar that for the sweep command there must be one trajectory which can be created externally. So click on here, for example, in the datum, and click on sketch in, for example, in the front plane, and the command has been passed. So click on sketch and create a geometry. So again create a random geometry like this. Again a similar geometry, simple sine wave can be created, or any different shape can be created, just to make you understand like this. So this is the random trajectory here. So click on OK, and now again set it into the standard or isometric mode here. For example, you can make the other planes or datums off. So this is the simple trajectory in the front plane here. So now resume this command. So here you can observe it here. The very important thing that you will be observing here, other options are similar to like in the sweep command, as you observe normal to the trajectory section, plane control, or in vertical control, automatic. So leave them as it is. So other thing is, important thing is there, that in the sweep command here were actually mentioned that sketch means sketch was created externally and single sketch was used. So but here we observe that in the swept blend command here is a sections tab, separately added. So that means there can be more than one section. So remember, for the swept blend command, there must be at least two cross sections, because a trajectory has two ends, this end and this end. So at least there must be created two cross sections at least. This is the necessary requirement. That at least two cross section must be there, but more cross section can also be there. For example, you can use create 3 cross section, 4 cross section, 5 cross section, and as much cross section in the trajectory. So that has no limit. So here the creation of the section has two ways or methods. One is sketched sections and other is the selected sections. So as the name indicates, sketched sections means the sections will be created internally, but in the selected sections, like as we have observed in the previous command, that selected items, so that means the sections must have been created independently using the datum sketch command, so that they could have been selected simply by clicking on this radio button. So the if we have the previous sketches existing in the graphics window along the trajectory, so we can select them, but as we observe that there the cross section external sections are not there, so selected sections cannot be selected, so use sketched sections option. So here you will be observing that in the sections area here is written section, and here it is very important thing is that here is the numeric sign that shows undefined, so that actually I will be explaining to you a bit later. So just now, for example, click on sketch. So here you can observe that by default at this end the section plane, this is actually showing the section plane or perpendicular axis. So here for example I am creating a simple circle here of for example this suitable size, and now I am clicking on OK, and here you can observe that in the section in the circle here you can observe a numeric sign actually shows two segments. So what are these two segments? So that means actually two segments. So actually circle is a single segment, but here actually it treats its center as a single section and its boundary as the other section. So here are actually two sections like this. So for the creation of next section you will be clicking on insert. So we will be clicking on insert, and we will be observing that as soon as I am clicking on select on this sketch 2 and now click on sketch, so automatically the section plane will be placed on the other end here. So here you can observe that the here, so for example I am clicking on a circle of different size. For example I can make its random size here. So you can observe that this circle is of larger diameter and this is of smaller diameter. So now click on OK, and here now you can observe that the command has been executed. And very important thing is that in the segments tab here, this is actually showing the number of segments must be same in all section. So if it is written 2 in the first section, so in all section there must be written 2, and if we had actually used further more sections, so they must all have the same number of segments. So the section location is actually the other section for the section 2 is at the end, and for the section 1 is at the start, means here. So in this way this command in a simple way has been demonstrated like this. And furthermore you can use its other options like thicken sketch. For example here you can click on, and for example look its exaggerated view here like this. Here you are observing some way here some merging is taking place, and for example click on OK. So observe it here. So the command has been successfully executed. So like this. So at this stage, demonstrate another important phenomena. Demonstrate another important phenomena. For example, uh, you have observed here in the section tab that the number of segments must be same in every section. But if for example I am deleting this first section, for example I am removing it, so I have removed this section. So what now I am doing, I am again sketching it here like this, and now instead of creating a circle I am using, you can say here, this is the construction point. Remember, this is the construction point, and I am just clicking here and making just pressing this point, and now I am clicking on OK. Here it shows the section must contain geometric entities for this feature. So just for a moment. Here for example, so I was actually demonstrating that I had actually, for example, removed this section here, section 1, for example I had removed this section, and I wanted that this section has been removed here, and I had clicked it here on insert and inserted section 2 on this end and click on sketch. And here when I had used this construction point, here you can observe, so I had clicked on OK. So it says that section is incomplete for reasons listed in the message area exit sketcher. So section must contain geometric entities for this feature. So you will be observing that I have tackled this issue. For example, I am clicking on here, for example I am clicking on exit sketcher here like this, and for example I am making this command cancelled like this. So what you will be doing, that you will for example be deleting this swept blend command, and here the trajectory is actually already available. As you can observe, this the trajectory was available because that was actually created using external sketching. So click on swept blend command again, click on swept blend command again, and here again like this, for example the command to be used was swept blend command. So click on swept blend command, so the trajectory, so you can select here this trajectory here, and here now this is the section tab. So on the sketch sections, this is the first section. So what you can do, click on sketch here, or you can again for example cancel it out. You can click on the here this is the start. And for example now click on sketch here and click on circle like this. So just create a circle similar to that one created previously. So click on OK. Now click on insert, and select this sketch tool and click on OK on this, and now use this construction point again. And here now you will be observing that you have observed that this is not the geometric entity, this is the construction point, but now this command will be executed successfully, as you have observed here. So a sharp tip model has been created like this, you can observe here. Here important thing you can observe here, in the section 1 there are two segments, but in the section 2 here is one segment. So that means if you use one section as the point section, then the point must be construction point, and it contains only one segment. So you have verified one important thing again here in the section 1, because here were listed two segments. So how these were two segments? Because one was the center of the diameter and other was the boundary of the circle. Because here it shows that a point is the one section, so circle center is the one section and circle boundary is the second section. So two sections and this is one section. So we have actually learned very important feature and important conclusion here, that the number of segments in each section must be same except when the point cross section is used, because if the point cross section is used, then only one section then only one segment can exist there. As we have observed that the point has a single section, one section. So like this, click on OK and the feature has been created. So such type of complex geometry cannot be created using the external other commands. So in this way point section has also been demonstrated. So here again a very important thing that I can make you demonstrate is that, for example, we can use three cross sections. So how three cross section will be used? So again I am deleting this sweat blend feature, but the trajectory is there. So what we will be doing, so the trajectory will be modified. So how that modification will be used, will be applied upon the trajectory. So click on sketch 1 means the trajectory, and click on edit definition here. And what we will be doing, that we will be clicking on this here in the editing area, divide command. So for example, if we want the second section or third section to be placed anywhere at this location upon this trajectory, here, and any location. So for example, I am clicking on here, you will be observing. So here you will be observing that the trajectory will be split up into two segments, two portions. One this is portion and this is the second portion, because this point has actually randomly divided. So here the third section will be placed. But very important thing is that now three cross section can be placed here. One section is, for example, here, second here, and third here. But those section will be created orderly, not disorderly. Means, for example, first create this section, then create this section, not this section. So those section will be created orderly, not disorderly or in a random way. So click on OK. The trajectory has been created, modified. Now click on swept blend command. swept blend command. For example, now I am selecting this trajectory here, and again for example I am starting from this end, and now I am in the section tab, and now because this section 1 is by default here, so click on just sketch, and here for example I am using a center rectangle. I am using a center rectangle here like this. You can observe just a random section, you can say a suitable size. So click on OK. So here you will be observing that a center rectangle has 4 number of segments. So what we will be doing, we will be for example clicking on section 2, and here the number of here click on sketch 2, and here is by default it shows on the end. So what, but you want that section to be located where you had created that division point. So how you will be detecting that point? So for example click on front view here, and what you will be doing, that you will just be hovering the cursor very precisely, accurately and very carefully along this trajectory, and you will be observing here. As soon as you will be in the vicinity or nearby that point will be highlighted. So this is actually the point where the divide command was used here. So click on this point here, and it says end curve F5. So now click sketch here. So here you can observe that this is actually the point, and here for example you create for example create a circle command, or for example you are creating a circle. But as you observe that for the circle there are by default 2 segments. Or what we will be doing, because this rectangle has the 4 segments, so we will have to divide this circle into 4 number of not equal or any random segments. So we will be using this divide tool command, and for example we can zoom in this area like this. Click on this divide tool command and click on for example here, click on here, so here and here. So now you can observe I have created 4 segments, 1 2 3 and this is 4 segments. Here very important question that the student might ask, that I have initially told you that the center is 1 segment and the boundary is the second segment. So that was when the complete circle was actually existing, but now when its boundary is divided, then the center point is not actually treated as the separate segment, so only the boundary segments are considered. Here you will be observing, as soon as I am clicking on OK, so you will be observing here that the model will be actually being created. So here like this. So now click on insert, and for example now the third or last section will be created by default at the end, so that is okay. So just click on sketch here, and for example just to save time I am again clicking on using the center rectangle command here like this, and I am creating a random rectangle here like this, and click on OK. So here you can observe a random shape has been created that might not be accurate or practically feasible, but that can further be actually modified, or those points. So here you can observe that in all segment in all section there are equal number of segments, and like this. Yeah. Front you can observe. Again we can create these bends by controlling the sections like this. For example, I am again clicking on edit definition and go into the section tab. For example, in the section 1, for example, in the section 1, for example, I am clicking on sketch 1 here, like you can click on sketch view here, and here for example I am selecting this rectangle and I am using the rotate and resize command here like this, and I am just rotating this here, for example, at some random angle, and now I am clicking on OK. So here you will be observing some difference. So here you can observe this section has been rotated. So here you can see some difference. So that means the section's rotation can be used to create more accurate or more required geometry. For example, you can also rotate this section here. As you can observe it here, the body is actually is not defined, or it's actually the section is actually sections are actually merging. The body thickness is not actually defined. So we can, for example, rotate this section at some angle. So how we will be doing that? For example, this was actually the third section, so click on and click on sketch here, and now for example you can click on sketch like this, and again you can zoom it, for example, and click on select it here, oh sorry, like this, and click on rotate and resize, and for example just rotate it at some arbitrary angle at any location here. So you will click on OK. So here you can observe the difference. Observe the difference. There is the difference. So in this way, that sections can be rotated to control the geometry like this. So this thing has also been demonstrated. Furthermore, again, for example, we use the point section, and note an important thing here like this. For example, I am removing this third section. This third section has been removed, and again I am inserting the third section and clicking on its sketch, and now I am using, for example, again the construction point as the section. So observe the difference, that here important thing that you can, as soon I am clicking on OK, I observe that the command is failed, because actually the due to the previous two sections, actually the body size is not actually defined at this portion of the trajectory. So that might be corrected using the further rotation of this section, or creating or varying the size of this section, for example, so that might affect that might affect uh, for example, you can click on sketch 2 and go into the sketch option here like this, and for example reduce its size, here like this. Again try. Again the command is actually failed, because if you click on OK, still it is actually giving issue. So again click on hit here, and again for example try to undersize it, or you can use the rotate option. For example, here it is just an hit and trial. Yeah, as you have observed it here, that you have just rotated wonderfully, that now that point section has been applied. So this is very important thing, very important demonstration. Like this you can actually hit and try, and the command will be successfully created. So the important thing here is that for the point section, when there are more than two sections, and you want to use the point section, remember the very important thing is that the point section must be on either ends of the trajectory. Means the point section cannot be located within the trajectory, or in the center of the trajectory, or midway the trajectory. That must be on the either ends. So in other words, that means that all the section must be on one side of the point section. On the other side there cannot be the other section. And again the point section can be used only upon the end of the trajectory. So for this trajectory, because it has two ends, so only two sections can be two point section can be used when there are total three sections. Because if we want to use only the ends of the trajectory, and as there are two ends of the trajectory, so when two sections are used, both cannot be the point section. But if there are three sections, then the end section, both end section can be point section, and the middle section can be any other section of, for example, rectangle, circle, but cannot be the point section. So all three sections cannot be the point section, because that actually not be defining the any body having dimension or sizes. So the point section, important information or features about the point section that you must keep in your minds, that the point section is always used at the end of the trajectory, not in the midway in the trajectory. And if there are only two sections, so both cannot be the point section. One of them must be some section having appreciable size, for example circle, rectangle, and the other section can be the point section. But if there are total three sections, the point section both the point sections can be placed on the ends of the trajectory, and the middle section will be some section having suitable size, circle, rectangle, or pentagon, hexagon, etc. Any other section having suitable dimensions, not the point section. So these are important conclusions. I hope you understand. If you have still any question, you can fairly ask. You will always be welcomed. So here you can observe, here you have demonstrated this command using the internal section. So here tendency control is like this. Okay, options are similar. Okay, body options okay, properties okay. So in this way internally this command has been demonstrated. So next important thing is that I will be demonstrating this command, swept blend command, using the internal external section, means selected sections. So how the selected sections will be demonstrated? So let us delete this command, and you will be observing an important feature like this. For example, now the trajectory is there. So what you will be doing, if you want to use the selected or external sections, so actually you will be creating various planes. For example, you can show the plane display here like this. So here for example you look it at the front. So as you can observe here, for example, I am using this plane as the section plane. So I will have to use two further planes parallel to this plane, and the planes will be placed upon the ends of the trajectory. How? So click on simple plane and click on this plane, and now you will be pressing the control button from keyboard and bring the cursor here and upon the trajectory, and you will be showing end curve f5 etc. So you will be clicking on here. So as you can observe that the plane is placed here like this. And once again, for example, I am creating another plane parallel to this plane upon the other end of the trajectory here like this. Press control button, first select this plane and then press control button and then select this end of the trajectory and click on OK. So furthermore, if we want to create further sections, means 4 sections or 5 sections, so other planes at suitable distances can be placed. So what now we will be doing, that we will be creating external sketches. Like for example, I am selecting this plane and clicking on this sketch, and again for example I can zoom in, and now for example you can place center rectangle like this here of suitable size. Now click on OK, and again click on sketch and click on the second plane here, and here again for example you can create a center rectangle just to so that the sections number of segment in each section are same. So just to save time, or you can create a circle as well, use the divide tool command to create equal number of segment, but I am just using the center rectangle command just to save time. Zoom in here. So here for example by observation just in this plane, for example, I am creating rectangle here, and I can, for example, further rotate it at any suitable angle. This rotation is optional. This rotation is just optional. This rotation is just optional, like this. Just zoom in here, like this. Sorry, here. Okay. And furthermore, for example, click on OK, and after that, for example, I'm clicking on sketch, and then this plane, click on sketch, and again zoom in this portion as well. So for example, I'm using simple line command and create a random profile here. Sorry, four segment must be there because I've used rectangles, so I am using a simple quadrilateral like shape. Click on OK, and now you will be launching the swept blend command, and in the trajectory just select this trajectory as previously you have selected, and in the section tab now click on selected sections, and this is the section 1. So in any order, for example, you can click on this section. Okay, and now click on insert, and the section 2, and now you will be selecting this section. So here, as you will be observing that the model is being created, the preview is shown. So remember, if the preview is not shown, that means the command is failed at this stage, so you will have to modify the section. So click on insert, and now this third section like this. So click on here, here. So here you can observe as the preview is not shown. That means the command will be failed. So what you will be doing, that you will have to rotate this section at some suitable location so that the corresponding points are merged into each other. So click on again, activate this command, and what you will be doing, that you will be actually cancelling this command, and you will be modifying the rotation of these sections like this. For example, that was actually the you can say first section. So just for example, try to rotate select it here like this, and for example rotate it randomly at some angle, and again try. So this is hit and trial, so we will have to try many times because we are actually creating a random shape. So again go on to swept blend command and go into sections and selected sections, and again so click on this section, click on this section. Okay, sorry, just a minute. So click on swept blend command, and click select this trajectory first, and then go on to the sections here, and click on section 1. See the start point of the trajectory. The start point is here. Click on this arrow, simple. So if you want to start from this end, so just click on this arrow. This is very important. So again, just zoom it further, click on sections, and now click on selected sections. Click on selected sections and click on this section like this. Now click on insert and go to the second section here and select this section. But again observe that the preview is not shown here, so that means the command will be failed at this stage because you have observed. So the simple way is that we will be rotating or modifying those sections. So the only what we can do, the rotation is important. So again here you can observe, for example, one important thing actually. Click on reference tab and just zoom in this portion. So in the section tab, for example, click on this section 2 and you will be observing a very important thing is here. Just in the section tab, when you click on sketch 2, so here this start point and of the click on this arrow here like this until, for example, model preview should be shown to you here. Sorry. So what you will have to do, that you will be again modifying the rotation of these sections. So this is very important thing. So what you will be doing, for example, click on sketch 2 or sketch 3, for example, and modify it like this. For example, we can change its size. Randomly. Approximately. So again try to create the sections, remove this section. So this section is our section and click on this section. Again preview is not shown, so that you must understand that the command will be failed automatically. So that is the important thing. uh, make it cancel. Again delete this command and modify the sections and make their sizes smaller. For example, in the sketch 3 the size of this section is much larger. So if you actually some constraints are actually applied. So here one important thing is also that the section actually somewhat looks similar, or you can say parallel. The section plane looks parallel to the tangent to the start point of this trajectory. So as the default option is actually the section control must be normal, so that actually also affects the creation of this model. So click on, for example, sweat blend again. So here it is shown the sectional plane is normal to the trajectory. So we can also, for example, hit normal to projection. We can click on normal to projection. So it says the direction reference. So it is very important that the section plane is normal to the projection, normal to the projection. For example, you can click on this line as, so that means the section will be normal in this direction. So let us try it just for the time being. Click on selected sections and click on this sketch, click on Z and go to the next section. So second section, click on this section. So again the preview is not shown, that means this command will be failed. So you can actually for example you can delete or remove these sections, because actually this is the random demonstration. So for example you can just use the circular section for the time being, just a simple demonstration. For example, click on external sketching. This circle, and now click on, for example, simple circle. Just zoom in here like this, and on a circle of smaller size as much as possible. And again click on OK and click on sketch to the other plane, and just zoom in this as well. and use a circular section of further different size. Click on OK. And again click on sketch and go into the third plane like this and click on circle. Sorry, not here, close near the end of the trajectory by observation, just here first. Click on OK, and now click on set blend command and select the trajectory, and in the section tab and just zoom in these portions again. For example, start from that end and just zoom in here, and on the section tab click on section and click on section 1, sorry, selected sections, and up on this and click on insert, and again click on the second section. So sections, second section, sketch 2, and click on this circle. So here you observe that the command is being executed. Click on insert, and in the third section again here like this, go into the sections, and in the third section click on it here. So here you can observe. So actually the reason simple, because in the circle command actually the rotation was not actually necessary, so that has been actually executed. But in the previous case, when we had used actually the rectangular portion or rectangular sections, so that you will be trying and you will be observing that will be actually successfully demonstrated after applying the rotation of the sections. So sorry, actually at this stage I am actually very tired. So as for this lecture, at this point we have actually covered simple sweep, helical sweep, and swept blend. These three swept blend, swept blend command. And further in the next lecture we will be demonstrating the blend command starting the. So sorry if you have got any inconvenience. Thank you. Assalamu alaikum. God bless you.